So you're free to just go ahead and send your questions in the chat. I'll do my best to watch it really closely. I have it on a different monitor, so that means I might miss something for a second or two while I'm working on another problem. I'm going to go ahead and switch my share over to, where is it? The practice test I was sent. So I received something like this. Did you receive something like this as well? Awesome. Okay, so I wasn't planning on working through all of these problems because it is a little long to try and get through in an hour and a half. But were there any problems you specifically wanted to work on? And I can either explain that process or help you work through them. Whether the equation is odd or even. Okay, and then what problem numbers are those? And I can run through one of them and just talk about some of the general stuff associated with that. Okay, let me see if I can find it really quick. Okay, so it looks like 19 through 22 would be the questions that you're looking for. I'll go through like one or two of them so that we can talk about it and why they're odd or even, but I would definitely recommend going through all of them. So generally what it's talking about when I think odd and even is, and let it turn on my annotations so that I can actually draw. So let me switch to a darker color. Okay, so when we're talking about an even function basically means, and then let me know if you can't see this, because I know it's kind of a dark color on a dark color, and that can be kind of hard to see sometimes. But an even function is just any function that's reflected over the x-axis. So it should look exactly the same between the x-axis, between the negative side of the left of the x-axis, so like over here, and the positive side of the axis, which is over here. So this appears to be even. We would want to check analytically, but some function, same little graph here that looks like this, because it has an axis of symmetry, but the axis of symmetry is not the y-axis, then it's not even. It's not considered even. Okay. Whereas when we're talking about an odd function, the most common one is like the cubic function, and I like to think that it's, so if we took this side and we flipped it this way and then flipped it this way, they would line up perfectly. Or they're reflected over the origin. That's the idea. That's kind of what you're looking at, is even this quadrant and this quadrant are exactly the same. Or this quadrant, when I swing it up 180 degrees, it's the same. It lines up perfectly. All right, so that's the visual idea. When I'm talking about the analytical idea, it's just remembering that for an even function, when I plug in a positive number and when I plug in the negative version of that number, it's the same. And then when I'm talking about an odd function, f of negative x is equal to negative f of x, which is essentially saying that if I plug in a negative number, it's the same thing as negating whatever the solution was for the positive answer. So if we're talking about this one right here, because it's cubic, I know that it's either going to be odd or neither, but I'm still going to go through that process of how I would check if it was a little bit trickier to figure out, like let's say it was a rational function. So we're already given f of x, so my first step would be to plug in negative x and see what's going on there. So when we plug in negative x, we get negative 3 times negative x cubed plus 7 times negative x, and then I want to go ahead and simplify. And so when I simplify, this just becomes negative x cubed, where the negative 1 is still there, but it's no longer inside the parentheses, multiplied to negative 3 minus 7x, and so then that first one becomes, and this whole thing becomes 3x cubed minus 7x. And so we can see right away that our original does not equal the function that we get when we plug in negative x. And then if you feel more comfortable with it, what you could do is do like, see if f of 1 is equal to f of negative 1, which based on just this general process that you do with these variables, they don't equal. Now what I would do is, since I have my f of negative x, I'm going to go ahead and erase the work I did to go ahead and find that. Now I'm going to go ahead and look for negative f of x, right? And so that would just be taking a negative number, and so doing like a negative out in front of the original function. So that would end up being 3x cubed minus 7x. And so since this guy is equal to this guy, that would indicate that 19, the function in 19 is odd. Okay. I actually think looking at these, all of these, oh no, not all of these are going to be odd. So for example, like if we were to do the same process with 21, the process would be f of negative x. I would go ahead and plug in like before, negative x, or negative 5 times negative x cubed plus 8. And then when I simplify, I end up with 5x cubed plus 8. Obviously, this does not match this. So g of x does not equal g of negative x. And then I need negative f of x, which is going to end up being 5x cubed minus 8. And so then we can see in this case, g of negative x does not equal negative g of x. And so since neither of these are true, that's how we would make that connection of odd. Okay, any questions about this type of problem? Okay, any other things I can go ahead and clear up or explain? I know I saw some piecewise functions on there, and piecewise can be super rough. Okay, well, if you want to go ahead and leave, or you do find other problems, I'm going to go ahead and go back up to the top, because this is going to get posted to YouTube later, to like talk about some of these processes. I'll probably try and do one from each section, but you're welcome to hop out as well, or you can stick around as I'm running through these problems, and when you do have a question, just go ahead and ask. Okay. So, like I mentioned, I'm now going to go back up to the top. Okay, so it looks like the first little part is about functions, and whether or not we're talking about continuous functions or non-continuous functions. So these first ones are talking about a relation. Basically, that just means I have a set of points, but I may or may not have the function that defines the relationship between those 2 points, and then I want to know what the domain and range is. So I have a little song that's been stuck in my head, lived in the back of my head for almost 9 years. And the idea is, it's a song, and it goes, a function, the domain is all inputs, all x's, the range is all outputs, all y's. You cannot have the same values of x for different values of y. And that's always what my brain goes to when I'm doing this. So the domain is all inputs, all x's. So whenever I'm talking about these kinds of points, right, they're given as x, y, and our common notation is that x is the input, y is the output. So in each of these, I'm going to go ahead and take it and then plug it in. So like I have 1, 6, I have a negative 8, I have a positive 8, and I have another 6. So I have 6, 8, and negative 8. And so that would be my domain. You might want to put it in order, but I'm not going to worry about that because that's not the big idea here. And then the range would then be all the y values. So I have 2 5s, so I'm only going to write 1. I have a 10, and then I have a 15. Now it's asking, does the relation represent a function? Well, for a function, I can't have the same values of x for different values of y, right? So I noticed I have 2 6s for my x inputs, but they're associated with different y outputs, right? One is 6, 5, and one is 6, 15. So if I was dropping it on a graph, then I would have something that looks like this. And obviously I could do my vertical line test and see I have an issue. So this is not a function. And so with these, that's kind of what you'd be doing for these relation ones. Okay, there's some more. I would definitely recommend going through and doing this. So when I see these function ones, in fact, these 5 and 6 are exactly the same. There's a couple ways you can go ahead and deal with this, right? I can go ahead and solve explicitly for y, right? And so I would take the square root on both sides. The thing I would note is when I take the square root on the other side, because it was not there originally, I should have a plus or minus, right? And so that when I plug in any value for x, like let's say we just plug in 0, then I have plus or minus square root of 1 minus 0, which is plus or minus square root of 1, which is plus or minus 1. Well, then when I plug in x, I get 2 outputs, and so that would indicate to us that something's wrong. Generally, if you don't have an explicit y equals, or in the process of doing a y equals, something janky happens, like this, where I'm taking the square root and so that I get the plus or minus, that would help us define whether or not it's a function. The other way that you could go about doing this is moving it over, because you may have seen it before, but x squared plus y squared equals 1 is relative to the equation for a circle. You might have seen this before, you might have not. It's just another way to go about it. And so then you could just draw a circle and consider it your vertical line test. And so you could drop it anywhere, and only at these points at the end are you only going to hit 1 point. And so that would define this, make this not a function as well. Let's see. This one's talking about domain, so it's super important for us to remember some of the domain restrictions associated with different types of functions. So remember, whenever I have a fraction or a rational function, that's what 7 and 8 are, I always need to check the denominator, right? Because if I can't divide anything by 0, that causes problems, right? So when I have a function that is a fraction with variables in the bottom of the fraction, I need to observe and take note of when the things in the bottom of the fraction are equal to 0. And so in this case, right, I would consider when x squared minus 4 is equal to 0, which would end up being when x is positive 2 or negative 2. There's a couple ways you can go about doing that. Try and get that to yourself. So that's what I would note. I don't notice any other domain restrictions. Sometimes you might have additional stuff going on in the numerator, and so you'd want to identify that as well. But whenever you're dealing with a rational function, you're just going to check the denominator and see when it's equal to 0. Then we need to go ahead and write it in interval notation. My only thing is x just cannot equal these two, and then I'm totally fine. So I would be able to write it as negative infinity to negative 2. It depends. Okay. So with interval notation, we have 2 ideas. You can either do a union sign, which is that big underline, big uppercase U, but without its little tail, and then negative 2 to 2 union, 2 to infinity. Or if your professor doesn't really expect you to understand the unions, just go ahead and put commas in between. It's the same idea. It represents the same thing. Okay. So then you would go ahead and do that. 8 is exactly the same. You're just going to take the bottom of that fraction and set it equal to 0, solve, and then those are where your domain issues are, and then write it in interval notation. Okay. Now this is the other half of the little song that I have stuck in my head. A function is defined by dropping a vertical line. It can only hit 1 time, and that is a function defined. It's essentially a vertical line test, right? So the nice thing here is they give us the function. Although function is not technically the correct term, because, you know, we can only have all this kind of stuff. We have a visual, right? And so because we have a visual, it makes this pretty easy to test field the vertical line test, whether or not this is a function or not. You drop 1 vertical line, it hits 2 times, Therefore, it's not a function defined. Sorry, I'm having a really fun time saying that. And then here, this is not a function, this is not a function, this is not a function, blah, blah, blah. So go ahead and clear. And then scroll down. So let's see if there's one. Same thing, vertical line test, and then I observe whether or not it's a function. Here, now we're going to consider whether or not it's a function. So this one, to me, does appear to be a function. Right? It doesn't hit all of the x values, but if I drop the vertical line at any point, it's only going to hit once. So I would say, yes, this is a function. Every vertical line intersects the graph in at most one point, so that would be D. And then if you're like doing this on a computer or you don't want to draw a dozen vertical lines, a really good way to like go about doing it is if you have an extra piece of paper, just kind of, especially if it's a different color, that would be awesome. You can kind of skim it along the whatever you're trying to figure out is a function or not. And if there are two places where it's popping out of, then that would be a good indicator whether or not it's a function. And then whether or not it passes the vertical line test. So like in this case, we talked about this is D. To me, this is an open circle. So to me, that's going to indicate that we start at -5. And then my assumption additionally would be that I have a vertical asymptote along the y-axis. So this is going to go to 0. And then because I have an open circle on one end, remember an open circle basically is saying I have everything up until that point, so I can get super, 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 super close. Because like -4, that is a 5. I said 4, but I wrote down 5. -4.9995 is super close to -5, right? But because it's not -5, it's fine. I can plug that in and have an output point. So that's all that that circle means. But whenever I see the open circle, I should always associate that with a parenthesis sign rather than a bracket. Similarly, when I have those asymptotes, same idea. I can get super, super close as I go further, further down forever, but I'm never actually going to reach where that asymptote is, so it also gets a parenthesis sign. And then when I'm talking about my range, so when I'm doing this on paper, I literally like to trace it with my fingers. So what I would note in this case is this, I have this arrow pointing down, which is indicating to me that I'm going down forever and I'm continuing forever. So I would assume that my lower end of my range is -infinity. And then I would go ahead and trace whatever my line is up until I have the point that it stops at, or the highest point that it goes. In this case, that's where this point is, and that point is -5, 2. -5 is associated with the domain because it's the x value, and 2 is associated with the range. Because 2 is that top point, it's going to indicate to me that this should be 2. Then I need to identify the intercepts. Remember, the intercepts are where we cross the x or y axis, and the x or y axis are where one of those variable values is equal to 0. So along the x axis, it's where it's where y is equal to 0, and along the y axis, it's where x is equal to 0. So then I just need to identify, it appears that we only have one, because again, I'm assuming that there's this vertical asymptote along the y-axis, so I'm never going to touch it or cross it, meaning I have no y-intercept. And then I just need to visually identify what the x-intercept is, which to me, it looks like it's right here, and I would say it's -1, 0. It's very important that you identify what the scaling is on the bottom of the graph. A lot of times in my math lab, you can zoom in. So that's a good little tool to use to figure those things out. And then remember, just symmetry means that you can flip it somewhere or some way and it'll look the same. We talked about how symmetry along the y-axis, that would be like, so the vertical one is the y-axis. The thing is, functions can't be symmetrical over the x-axis, because then it doesn't pass the vertical line test, but it is a potential for it to happen. If it's symmetric with respect to the origin, it is odd. If it's symmetric with respect to the y-axis, it's even. So odd, even, not a function. So just keep that in mind. So if you do identify that it's a function, it should not have symmetry over the x-axis. If you do identify that it's a function, there's a possibility that it will. So we've identified that this is a function. So the x-axis stuff doesn't make sense for us, and then it doesn't appear to be odd or even. So that would indicate D, this has no symmetry. Okay. Same process and with a very similar problem. Now with this one, it just wants you to follow through and answer all of these questions. So you're just verifying this stuff. So like in part A, you want to know if 4, -15 is on the graph, which just means you would need to verify that when you do f of 4, it equals 15, or -15 rather. So you would do f of 4, which is equal to 4 plus 10 over 4 minus 6, and see what that equals. It does not appear that it's going to be -15, just so you're aware. So keep that in mind, that's what you're doing essentially. And then by that, we would get D. So go ahead and verify that on your own and make sure that you understand why. That would be the solution. So then with the next one is if f equals 1, or x equals 1, what is f of x? So it's saying that the input value I'm given is 1, and it essentially wants the output value. So for the second one, I would be doing f of 1, which is equals blah, blah, blah. I do believe, so this would be the output value. So if I were to plug it in real fast, we get 1 plus 10 over 1 minus 6, which equals 11 over -5. So that would go here. And then this would be the point. So you've plugged in 1, that is the x value that is associated with this point, and then -11 over 5 would be the second point. Same thing with, similar thing actually with C, except now I'm going backwards. It gives me the output point. So f of x, just as like a little notation thing, f of something denotes that it's a function of something. So if something's not a function, like let's say we're talking about a circle, because we know a circle is not a function since it doesn't pass the vertical line test, that's never typically going to be denoted with an f of x thing, right? Instead, it's going to be denoted usually as a y equals sort of thing, and then we get crazier later on. So in this case, this is saying f of x equals 2. So sometimes I like to think about this in terms of some kind of point. I know that there may or may not be some x values such that my function equals 2. And then I would take x plus 10 over x minus 6 and set that equal to 2. And then I need to find the associated x value. So just as a reminder, right, we would multiply x minus 6 onto both sides. So we get x plus 10 is equal to 2x minus 12. I would add the 12 over here, so then we get 22, subtract that over here, this x onto the other side, which is just going to leave me with x. So that would indicate that this is 22. So 22, 2 is going to be our point. It's very important that you identify and start to get familiar with what x is denoting and what f of x is denoting and how to substitute them into the problem in order to get the correct solutions. And then we've talked about this, the domain, right? This is a rational function, so the domain has to do with the bottom of the fraction. I would not be able to plug in 6, because if I plugged in 6, I would get a 0 on the bottom of the fraction. I'm going to go ahead and clear this. I'm just going to go ahead and talk about the next two parts, which are list the x-intercepts, if any, and list the y-intercepts, if any. So to find the x-intercepts, what I do is set the function equal to 0. So x-intercepts I like to think about are being x comma 0, y-intercepts are 0 comma y. And so those are going to help you denote what values you're looking for and what values you're plugging 0 in for. So for x-intercepts, I'm going to take x plus 10 over x minus 6 and set it equal to 0, and then x plus 10 equals 0, x equals negative 10. So that would indicate that my x-intercept is at negative 10 comma 0. It's very important to identify what the question is asking for. Sometimes it wants the x value associated with the intercept. Sometimes it wants the intercept as an ordered pair. So if you're doing this test online, make sure to read the little blue parenthesis text under whatever the fill-in box is, because that's going to indicate how it wants you to actually answer this problem. And then I'm going to do the same thing with this. It's easier though, because when I do it, I get 0 plus 10 over 0 minus 6, which is 10 over negative 6, which is equal to y, right? Because it's equal to the f of 0, and that would be the y value at that point. So then I get 0 comma negative 10 over 6. Just keep in mind, I'm not simplifying, but this fraction you could simplify to a further form. If you're doing a paper exam, I would recommend making sure you have the correct form before you go through that process of simplification. In 126 and 127, professors still like to see that you understand how to simplify. But as like a general math tip, my recommendation is always to at least get to a point that it is correct, go through everything, and then go back and do the simplification. Because simplification's hard, we all struggle with it, and so having more time and being less rushed to do it can help discourage the possibility of those common mistakes happening. Okay, we're going to scroll down, blah, blah, blah. Same type of problem, so I'm going to go ahead and skip this. Definitely look over what these questions are all asking for and how to find it. Okay, now we're talking about increasing and decreasing. So just as a reminder, as like a side kind of thing, the way I like to think of it is if I'm tracing the graph, so like in this case, if I'm tracing the graph and I'm going down, that is decreasing, right? I can like between the 2 points where it starts and whatever this minimum is, I should be able to draw a line, and I'm going from left to right. Well, and that's some kind of straight line with a negative slope, right? So that would indicate to me that from here to here, it's decreasing. And then I could do it from here to here. And that, because if I drew that line, would go like this, from here to here, it's increasing. And I would follow that pattern. Decreasing, and then I'll fill this one decreasing, and then the other two are increasing. Super important. And then it's just typing those in, submitting them like that. So in this case, for the increasing, it looks like it's going to be I'm going to have to clear it. It looks to be from negative 10 to negative 4. This one says to use a comma separated list. So that's something that you should look for instead of like the unions that I was talking about earlier. Then I have negative 2 to 0, and then I have 3 to 5. Okay. And then generally how I've seen these problems when you're given exams is that, or even on homework, is that the increasing and decreasing are usually for the same problems. So when you line them up, they should meet each other exactly. The only other thing I can say is at those points where it's the top or the bottom, it's neither decreasing or increasing. And the reason is like because I can draw a point between these two lines, like a line between these 2 points, right? That means that I could draw a straight line with some kind of slope. Well, at those points, I can't draw anything, so I kind of think about it like a flat line. And so therefore, a flat line, horizontal line, has a slope of 0. And a slope of 0 is not positive or negative, right? Decreasing is kind of like a negative slope and increasing is kind of like a positive slope. Okay. Then here it wants you to identify local minimum and local maxima. Okay. This one actually is just talking about local minimum. So right, we have global minimums, and that would be the lowest point in all of the function and all of the graph. So something like a parabola that looks like this might have a global minimum, which would be this point. Local minimum just means that there's probably some point later on that's even lower. So in this case, it looks like I have one at -2 and +6. And then just something to keep in mind is that the way my math lab has this written up is sometimes x equals kind of stuff. Sometimes you have to input the x equals, but not very common. It depends on the type of question. The other time that this will be paired with is the value of that minimum. And when it's talking about the value of a minimum or a maximum, it's just talking about the output value, right? This is where it's happening. This is what the level of those minimums are, right? So in both cases, they're at -4, so that would indicate the local minima are 4, -4. And then you would do the same thing with the maxima. Same idea, just with relative maximum values rather than global maximum values or relative minimum values. But fairly straightforward, right? So this one's talking about minima again. So just keep that in mind. That one's exactly the same. We talked about these where it's asking if the given function is even, odd, or neither. Again, I just like to think about it in that process with starting with f of -x, comparing, and then doing -f of x and comparing. And then we get to our good friends, the piecewise functions. I believe I only have yeah. Okay, I'll do one of these, but I'll probably just talk about it. The important part when you're talking about these kind of questions, these two actually, is identifying what the process would be, right? So this just wants you to find the output values of the piecewise function there. So when you're talking about these, you need to identify the x value, and then the way I think about it is I need to identify the associated function for that x value. So like -1 falls into this interval, so I would plug a -1 in here to get the output value, so that would be 1. Here, this is 0, that's going to fall here, so this would be 2. And then for f of 3, because it's greater than 0, it's going to fall here, and then I would plug it in and get 10. So that's the process there. These are just really critical thinking where you're identifying where the x, how the x informs us of which function to use. And then the next one, which is the far more painful type of function, right? Piecewise, because I need to know more information about it. So when I'm talking about the domain, I really just like to look at these. And I ask myself, what is the smallest possible value I could plug in, and then every value in between, and the largest possible value. So in this case, right, these two inequalities line up really, really nicely, because this one says -infinity to 1, and I'm doing union of 1 to positive infinity, right? Because any number in here is always going to work here, and any number in here is always going to work here. And then when you have something that's this union, I kind of like to think about it as or. It just has to exist in one or the two, right? Because I have one interval where the 1 is not included, but I do have one where it is included, and I'm looking at it just has to be in at least one of them, I can simplify this to -infinity to infinity. So that's how I think about it. So I would just go about doing it that way. So if you have like complex, let me go check if it's, the next one's exactly the same in terms of its inequalities, but if you have more complex inequalities, this is kind of how I like to think about it. After that, we have intercepts, which are not fun at all when we're talking about these, because I still need to do the same process. There's two ways you can think about it. What I like to do is I know I'm going to have x comma 0, and I know I'm going to have y comma 0. So when I'm talking about my x-intercepts, I'm going to take both functions and set it equal to 0. Now, there might not be an x-intercept on either of these. There might be an x-intercept on both of these. And that is something that we need to consider, right? Okay, so in this case, right, I'm going to subtract the -4, so then I have -3x is equal to -4, and x is equal to 4/3. I'm going to do the same thing here. 2x is equal to 1, x is equal to 1/2. Then I need to know, so this function is delegated by x is less than 1. Is 4/3 less than 1? No. So this was a potential x-intercept, but now I found that there actually is no x-intercept, so those do not line up. Then I'm going to do the same thing here. This function is relegated by x has to be greater than or equal to 1. Is 1/2 greater than 1? No. So this possible x-intercept doesn't actually exist on our graph either. That's kind of how I work through the x-intercept ones. I find it to be the easiest way. Then when we're talking about y-intercept, which I did write down wrong, I hope you caught that, right? This should be 0, y. I'm going to take 0. I'm going to identify which function it falls under. So 0 is less than 1, so I'm going to plug it in here. So then I get -3 times 0 plus 4, which is just equal to 4. So that would indicate to me that 0, 4 is where my intercept is. And that would be the only solution here. You may have 1, you may have 0, you may have 3, you may have more. Just keep that in mind. That's the process that you're looking at with dealing with these. Okay. But yep, that is my only intercept. Now I need to do the graphing. There's a couple ways that you can go about doing it. One of the things I would suggest is, because we have 2 that meet up and 2 that don't, is looking at -3 of 1 plus 4 and 2 of 1 minus 1. So -3 plus 4, which is equal to +1, 2 minus 1 is equal to +1. All that this is doing is, because the whole function's domain is -infinity to +infinity, I want to know what's happening at 1 where we switch functions, and I want to see if they meet up. So this would indicate that when I plug in 1 into both, they do meet up, so I can disregard these 2. Then I need to know which of these has a steeper slope, right? It's rise over run, so this would be 3/1. And then with negative, it would go this way for a negative. So that would indicate to me that the stuff on the left-hand side of 1 should be steeper than the stuff on the right-hand side of 1. So I do believe A is the correct answer. And that's the kind of process that I will look at doing that. Then with range, again, I'm going to follow and literally trace my finger up and down. So in this case, I'm going to trace. There's nothing until this point, which appears to be where the 1 is. And that would be 1, 1. So that would indicate to me that I start at 1, and then I would continue tracing up, and I could go on forever. So it would indicate I can go from 1 included, because I do have a point output that will give me 1 because of this guy and its associated interval. And then again, I can go on forever. And then isolated value just means, like, instead of having a closed circle here, let's say there was an open circle right at where this potential vertex was, right? And instead I had a point way down here and there was an open circle. that would indicate to me that I do have a isolated value. Okay. Same problem, same thing going on. This is now when you're getting into shifts. So I learned this a while ago, but you can have any parent function. If you know what a parent function looks like, you can figure out like how you would use different types of shifts. So f of x minus h, this is always going to be a left-right shift, plus k is always going to be an up-down shift. This a, whatever, that's always going to be a vertical stretch. And then if you have something on the inside, like let's say you have, this would be a horizontal stretch or squish. You mostly see that b when you're dealing with other functions, like sine and cosine and graphing those, but don't even worry about it. This is like the thing that you're most commonly going to see, and then you have to just figure out what it goes to. So this is the parent function that I'm given, and I'm shifted left 4 units. So left is negative, so I would consider it as x plus 4, and then I'm going to do any function that is associated with this, which is going to be squared. Same thing here, x minus 3 cubed. And this one, because I'm going up or down instead of left or right, this would just be x cubed plus 1. And I think that's most of what's left on here is those shifts and associating what's going on here. I will point out that these are just shifts again. They're just shifts with square root functions. So I'll go ahead and do one of these. You know what? I'll talk about it, but the interesting thing about looking at these versus doing them on my math lab is the way that it's done on my math lab, you literally have to start with the original function. Maybe you've seen this now, and then assign the way it's been moved or stretched or whatever. So just keep that in mind. Like when you're doing this on my math lab, you could click, this is going down one, so you could click here and it's going to automatically draw it right here, it doesn't care. And then you would have to move it down 6 for that position. Besides that, it's just identifying domain and range. You can plug any number into a polynomial and get a number out. And then you just have to identify the range. Again, I like to trace. So once I did that transformation, I would end up with a parabola down here. And so I would start at -6 and then go include it because I can get it out and then continue on up forever. Same thing for 32, and then the last two are almost exactly the same. You just are now dealing with a square root function. So again, we can kind of consider that square root. This is the parent function, so then I'm dealing with some x minus h thing here, and same thing, x minus h thing here. So then I would know that because it's kind of inside whatever the parent function was, I'm moving left or right. Because it's negative and this normally is supposed to be negative, I know I should move right, which means it's positive. In this case, because it's plus 3 and it's always denoted as minus h, this is moving left. And then the important thing here, since we've talked about how what I think is the easiest way to like identify range if you have graphed it, the other thing to consider in these two problems is domain. Because square root functions are another kind of function that have specified domain that is really important for us to remember. If you don't know what that is, I cannot plug a negative number into a square root, right? Because what a square root says, like let's say I'm talking about 2 squared is equal to some number, is equal to y. So then 4 is equal to y. Then I can instead consider as x squared is equal to y, and I could plug stuff in there. When I'm instead dealing with the square root, the opposite, right? And I'm doing square root of 4 and I'm going backwards, right? It doesn't matter what's here. I can always get something out. But if I have like -4, at least one of these would have to be negative in order for it to be negative, right? And so that breaks what our square root does, because it's looking for two numbers that are exactly the same that will multiply to give me the original one. So the general domain of the parent function is going to be x greater than or equal to 0. It's fine to have 0. Square root of 0 is just 0, but it cannot be less than 0, right? So I would say the easiest way to find the domain of a square root is just to take what's under the square root and set it greater than or equal to 0, and then solve. So x has to be greater than or equal to 6. And then I would turn it into interval notation, bracket because of the greater than or equal to. 6 is the lower bound because x has to be greater than or equal to it. And then infinity is going to be my higher bound. I'm not going to go over range. I recommend you try that on your own because it's the same as all the stuff we've been doing before. But that about covers it. It mostly appears like you're doing generic kind of function things, understanding domain, range, output, odd, even, relative minimums, relative maximums, all that kind of stuff. Just take your time. This might be a good exam where you're looking at some general definitions and that kind of stuff. So you can go ahead and have that well known, because it does make things a little bit easier. Okay, that about wraps it up. Good luck everyone on your exam, and have a great rest of your day and or week.